Hmm. Mm, I think everything is ready. It's now 6:27 p.m. We are waiting for the student to come to the class, but I think the parents confirmed that the student will be a bit late. So yeah, at least we just try to wait. Okay, I'm gonna turn off the camera first. Halo, good evening, Widi.
Jadi pening.
Good evening, Bu. Baru pulang kerja, Ibu.
Iya,
Alhamdulillah, bisa gabung.
ini mouse-nya ini.
Ini sebagai siap-siap juga. Hmm,
Tinggal nunggu meja aja.
Halo, good evening, Widi.
Ini pening. Pulpennya
Have
itu.
you ate your dinner yet?
What?
Have you ate your dinner yet?
Not yet.
Ah, why? Is there anything?
Because I'm not hungry.
Oh, that's new, that's new. Usually you prepare yourself to have a dinner previously. Is there any specific thing you want to eat tonight?
No.
No, that's bad. That's bad. Well, I hope after this lesson you could find something to eat lah, because it's good for you. Because yeah, I would suggest that before you sleep that you please have your stomach full, right? To avoid any disease as well as starving at the middle of the night. And it's kind of really exhausting. To me, I cannot sleep with my stomach empty. Uh, so I try to eat something, anything, at least to avoid myself to not having that starving for in the middle of the night. Okay, so since that you haven't eat your dinner yet, is it okay for me to start, or you want me to suggest you for any kind of option for your dinner?
What?
Yeah, is it okay for us to start this lesson tonight? Because you haven't eat your dinner in case you need more energy, or you want me to first suggest to you for what you possibly could eat for your dinner.
No, thanks. Let's just start.
Okay, let's just start. Okay,
Yes.
but in case in the middle you want to grab some snacks, just feel free. Okay. Okay. I believe last week on the last meeting we already added on how we fencing, as well as what we call as measuring the perimeter, right, for the campsite. We also already learned on how that we try to measure based on the shape, the geometry of each campsite, including the square, rectangles, as well as the combination of either rectangle as well as the square itself, right? For example, we actually when we see a more complex shape, we try to segregate them into
Yeah.
different shapes. So it's easier for us to measure the perimeter itself. On the other hand, we already learned that the other way around to measure the perimeter of each geometry is just as simple as we just walk around from each side. So we measure that uh, for each geometry, we actually can calculate it in the simplest way without having certain knowledge about the formula, about the uh, kind of unique characteristic for each geometry. But the basic concept will apply the same upon all the geometries. So it's the model for you to continue this lesson. Okay, we now are going to add some spices into this fencing. Okay, so with more shapes, more geometries, where we are actually No, there are several shapes that actually could be measured, like I said to you before, right? There are like triangle, pentagon, hexagon, octagon. There are a lot of shapes that actually we could find beside of this, but the basic concept of measuring the perimeter will still be the same, right? For example, that I have a triangle and each side have length like 4 meters, for example, 4 meters, and it's equal to each other, right? It's just as simple that I just walk around through each side and then I try to put it into the additional as part of the operation, right? And I get the result of how many the parameters of that triangle. But in this case, the reason why there is like 3 multiplied by 4 is basically since that all sides in this triangle is actually the same to each other. So that's why I put it 3 times of additional of 4. That's why I put 3 multiplied by 4. Now what if the condition is one of the sides of the triangle is actually looks different after we measure them, either when we are using the ruler, either when we are facing the triangle that actually clearly stating that one side of the triangle only 3 meters. How do we calculate it? It applies the same way, the way that we use on the old method. We try to just add them all and we find the perimeter of that triangle. But another question is, would it still be considered as the triangle? Can you tell me? If let's say one side of that triangle is actually have different length, either bigger or maybe, longer or shorter, can we still call this as triangle? If let's say I put this,
Yes,
yes, because why?
because it still has like three sides.
Yes, correct. It still have 3 sides. That's why it's called triangle, right? The difference is only to what we call about that triangle. In Indonesia, sometimes we call segitiga sama sisi, sama kaki, ataupun sembarang, gitu. When we are having like some sort of that kind of triangle, as long as they have 3 sides that actually connected to each other, we can actually call them a triangle, right? But if let's say they actually have 3 sides, this one is first, and then this one is second, and then the third goes like this. Is that a triangle?
No.
No, right? It's just a random line connected to each other, and then we try to conclude that for every corner means that there are like sides or what we call. But eventually, even though there are 3 sides, but they are not connected to each other, so that's why we didn't call them as triangle. Okay, there are a lot of characteristics of the triangle. It's either uh each leg actually has the same size, the same length, right? It's what we call in Indonesia is segitiga sama kaki. But if let's say all the sides connected to each other, but actually have all different lengths in measure, right? We call them as segitiga sembarang, right? It's totally different to what we call, but how to measure in this triangle about their perimeter will still be the same. The thing would apply the same upon the pentagon and hexagon. This, for as long as we could identify, this is the first side, this is the second side, right? From this point to this point, the third, the fourth, and the fifth side, as long as we could identify this, all the length of each side, we could immediately recognize that there is actually pentagon as well as the hexagon. The thing is, have you learned about what if you only know one side of it? Okay, let's assume this is the pentagon, and then you only know this side is 4 meters. Can you tell me what's the length of each side after that? What's the length of each side?
Um,
If you only
like to
have
how to
this,
figure it out. So I think um, if all side is like the same, it would still be like the same side. And then for
it,
like the bottom one, if it's like half, you times it by two, so it becomes like the meters.
okay. So when it comes to the pentagon and hexagon, the unique is quite a bit similar to the square, right? So even if you only have one variable, one information I can say that the first side of this pentagon was 4 meters, you can definitely be certain that the rest is also 4 meters, right? It's rare to find that each side of that pentagon or hexagon is actually consists of different length. I believe it's just like happening in rectangle, in triangle, right? Uh, but in the hexagon and pentagon, once you could find that actually one side of them consists of 3 meters, 4 meters, and what's so called to whatever your ruler said, the rest of them would definitely be still the same. And the measurement for the perimeter would still be the same method, right? Like for this example, since for the pentagon, there are five equal sides. That's the characteristic of the pentagon. While on the hexagon, there are six equal sides. That's why we put it as like five times of the 3 meters. While on the hexagon, since we have six, which is six multiplied by two. Why pentagon called as five and hexa is as six? So it's just like in the measurement of the Greek or ancient Greek, right? Penta means five. It's just a trivia for you to know. Hexa in ancient Greek, so called as six. Is there any other things above them? Yes, there are like hepta, octa, uh, there are a lot of things. So it would be like heptagon, hexagon, and then octagon, something like that. Octagon means eight equal sides. So both of each side would consist of same length, right? But it this time there are like eight equal sides. Ah, now we put it into the measurement, the simulation for you to know. For the triangle, right? They have actually the same sides, and we measure the perimeter of this shape, actually 12 meters, let's say. But eventually, we also found that the hexagon, that, that the hexagon actually have the same perimeter, right? Now, I want to ask you again. I believe that you already answered this on the previous lesson. Would it be possible for different shape to actually have the same perimeter?
What?
Is that possible for different shapes to actually have the same perimeter? Like for this
Mm,
example, the triangle is same with the hexagon. Is that possible?
I think yes.
Yes. Can you explain me why?
Because maybe they have like this same amount of length and width, but just different shape.
Correct. In total, they actually need the same fencing as what we try to put it into the analogy. Perimeter is the fencing, right? They actually need the same amount of fence, but they're just being differentiated by the shape itself. And also the measurement of the perimeter is actually free from any, how to say in Indonesia in English, dependence. They are free from any dependence of what shape of they are. So whether it is triangle, hexagon, square, rectangle, and anything, any shapes that you would learn further, it's totally fine for them to actually have the same perimeter. It's just like you try to make them look differently. Okay, I believe we already learned this kind of thing on how to measure the campsite if we just imagine that shapes is the form of the way we visualize the campsite. And we try to put it in in the grid, Cartesian grid, as part of transformation. And we also already learned that both of the squares and also the rectangle would have the same parameters. Now, if let's say I have this mix, I would like to try to test you a bit. I believe we already reviewed this on the previous lesson. Can you measure what's the perimeter of this shape?
Okay, so at the very top is two blocks,
Okay,
and then at the left is three blocks, and at the bottom
okay,
is also three blocks,
okay.
and then the next one in like the right is one block,
Huh?
and then like in the middle it's two block. It's one in the middle, but like in the bottom middle it's two,
Oh, okay,
and then in the
okay.
top and then in the top middle is one block.
Oh, sorry, top middle is this one, huh?
Yeah.
Okay,
So,
and this one is
and
one.
plus all
Okay.
of them, I think. So
Mm-hmm.
2 plus 5. 5 plus 3 is 8. 8 plus 1 is 9. 9 plus 2 is 11.
Okay,
And
correct. The perimeter is 11 meters using the old method. Can you try to count it using the combination of each shape? Let's say I'm gonna separate this into three shapes. Okay. Can you try to put it into calculation to know whether your answer using the manual and using the your calculation will still be the same? Let's try to put it as this one is the first, and then the second one is this one, and this is the third one. Ah, okay. So let's try to tell each of them. For the first one, how do I measure its perimeter?
hmm?
For the first shape, how do we measure its parameter?
So like on the width
Hmm?
is
Width
yeah, width is like the height, right? The height
or the
is
height? Yeah,
block, and then
the height is the width. Okay, so we already recognize that the width is 3, right? 3. And then what's the length of the
One
first one? Should I add or multiply it? Plus one
mm,
or multiply by one?
plus one.
Plus one. Good job. Plus one. Is that all? Is there anything else we should add?
And then do it again.
Do it again as you say as plus or
Plus again, I think.
plus again. Okay. Plus again. I'm gonna write it again. Would that be enough? Or there is another
I think that's
what do you
enough.
do? Ah, that's enough. Okay, so how much would that be? Four,
Eight.
eight. Okay, nice one. What about the second one?
Second one is all one.
It's all one.
So it's just 4 times 1.
Four times all one. Okay. I think I read it correctly, right? Okay. Uh, how much would that be?
4.
Five and four. Okay, four. You got me. Now the third one. We know this is the rectangle. The width is one. Am I correct to put it as the length would be three?
No.
No. So which one? That's actually correct. What's the length of this third rectangle?
2.
Two. Okay. I think this one is also the same with the first one. Should I put it two times like this?
Yes, I think.
Ah, okay. So how much that would be? Six, I
Um,
think. Yes.
yes, 6, yes.
Now, if we total them all, how much would that be?
Mm,
8 plus 4 plus 6,
8 plus 4, 12. And 12 plus 6, 8, 18.
18. Ah, but the answer is different compared to the conventional, the way that we just try to walk around. But turns out that the answer of all the parameters is actually different. So what's missing? Which method that actually shows the right result? What do you think? On the first method, let's try to look it again. On the left side, it actually consists of three blocks. On the bottom side, it also the same. Going up one, since there are no other blocks being blocked in this shape. Two, one, 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 and two. Okay, if we try to add literal calculation of the way we measure the perimeter based on just measure the outside, the outer ring, we could find that 2 plus 3, 5 plus 3 is 8. Add another 4, I think, 12, right? 5, 8 plus 4, 12. And then we add the last 2 is 14. Okay, now we found that the new answer for the just walking by, is actually 14 meters. Can you confirm if my result is the correct one?
I don't know.
Ah, remember the basic thing? When we try to measure the parameter, it's just similar on the way that we just walk around on the outer side, right? That means this is 2 plus 3, 5. Add another 3. I believe that would be 8. And then we have 4, 1 right here. So that means 4, right? 1 multiplied by 4 is 4. 8 plus 4 is 12. And then we add another 2 as the addition. So 14. Now, let's just assume that the walking by is just the correct one. What about if we separate them into different shape? Okay, so we already know that this width is 3, but for the length, there would be only 1 meter or 1 block. So it would go the same. It's just like 1, 1, 3, 3. We measure them as 8. For the second shape is the square. Since both consist the same length, that would be 4. 1 multiplied by 4 is 4. The third one is 1 plus 2 plus 1 plus 2 means it is 6. Ah, now the answer is also correct, but there is one thing that actually makes this true is when we actually separate it into three different shapes. Uh, let me try to visualize it to help you to understand that. When we try to separate each of that shape, it would be like this. This is the first, this is the second one, and then this is the third one, I believe. Ah, I cannot draw a straight line. Okay. The first thing that you would directly notice is there is a difference towards what we understand about what is perimeter against what we see right here. Perimeters is similar to something like we are walking outside of the shape, right? Correct? Correct or not?
Yes.
Calculating the perimeter is similar, like we are walking off the
Yeah.
outside, right?
Yes.
We didn't actually walk inside, right? That means it would be the area right here, the area right here, right? We don't actually walk inside of it. We just simply pass them through, right? To whatever junction that we met. We just simply, okay, this one is full stop. I'm gonna put it to the right, and then it's just full stop, and then I'm gonna try to put it to the top. Okay, but when it comes separating each geometry into each different to their different shape, that means the same logic, the same understanding to measure the parameter will also apply the same, right? The first one that we found that is actually connected to each other when we separate them into different shape means this area is no longer being part of the inside of this whole shape, right? Same goes with this one. This area means totally different compared to each other. That's why we found the different answer upon the way that we measure the parameter, right? The first that we thought as part of the being the inside of the initial geometry. Now then, being put as the part of the outside. It's just similar as just like we are having three campsites. That's what we try to. to align in this topic, right? If this we could imagine as a campsite tent that we built, and then we try to see it from the top, right? We could notice that this is actually one tent. Let's just call it as campsite B. But once we separate them all into three shapes, right? It's just as similar as just like we are having like camp A, camp B, and camp C. Ah, that's the false method on how we actually measure the parameter. And then if we already know this one is actually false, now can we persist to keep that the old method is actually the really good one to measure the parameter, right? Now, in my in my opinion, especially when seeing this, it definitely really comfortable for me still, even if I just walk around for the shape. I'm not sure whether you will think the same or not, but when it comes to measure the parameter, as it goes like this, as long as we already understand that parameter means measuring all the outer side, we just try to add them all into our calculation. What do you think? Do you agree with me?
Mm, I think yes, because that's how I do it usually.
Yeah. That means using the old method was not always a bad idea, right? And it doesn't mean when we try to be creative, we will get the same result on the manual one. What's the key point from here? For as long as you understand the concept, what's the perimeter? What is perimeter in actual? And then you try to combine that understanding into that calculation. So when it comes to a different calculation and it shows different result, right? It helps you to then to recheck, do we actually have the same understanding on the way that we measure the parameter? Why I tell you this, it's important for you to also to recognize when it comes to a different answer between you and your teacher, for example, in school, right? And you guys were using different method and it comes to different result. If let's say that you both having different method, but it goes for the same result, that's totally good. But when it comes to different method and different result, you both need to check whether the teacher has different understanding about the exercise or you actually have different understanding about the exercise, right? So from there, we could try or discuss about the actual concept. Like this one is about the parameter. Okay,
Okay.
sounds pretty understandable for you.
Oh yeah.
Yeah. Okay. Now we maintain the understanding. Yeah, we maintain the understanding that the parameter is something that we mean as walking outside of certain shape. But now I have several things. I need your help to identify this. If I have three shapes right here and I put different question into it, can you help me to answer both of these? Which one you would like to go first?
Triangle.
Triangle. Okay. So what's the perimeter?
3, 4 plus 5, 9 plus 3, 12. So comes 12.
Okay. Can you also write it right here? I believe that you could actually annotate in this meeting. You could
What?
try to I believe that you could also freely to write in this meeting on this lesson. Do you see on your screen that there is a pen symbol? on your screen?
Apa?
Ada simbol pensil nggak, Bu, di layar ininya, kelasnya?
Pensil.
Simbol, ya, simbol pensil yang biasanya dipakai untuk coret-coret ketika ketika belajar online itu.
Kemarin Weda yang tahu tapangan Weda ya. Kemarin Weda banyak belajar
Ini
kemarin.
di ininya udah nggak ada kalau ke ini udah keluar.
Kenapa ada suaranya tuh?
Iya tahu di sini. Iya.
Ini apa namanya? Ah, kakak masih gini ya online-nya ya.
Wah, iya biasanya juga ada, Ibu, di Zoom itu juga ada biasanya.
Ini kan
Coba.
Sebentar, saya juga coba cari.
ada.
Ah,
Ini mau jamnya nggak
control.
bisa.
Panggil Weda dulu.
Kan ini biasanya bisa kayak ini kalau udah keluar kayak ini
Nama juga lupa. Ini apa?
bisa
Kan?
bayar tuh.
Ini apa?
Nggak tahu buat kamu biasanya sih.
Ah, how
Ini
to
nih.
enable setting.
Yuk.
Ya, it's okay, Bu, kalau misalkan tidak ada. Nanti saya coba
Ada.
bisa bantu juga.
Kayak saya panggil Weda dulu.
Memang juga di layar saya
Oh, sudah.
kadang ada, kadang hilang gitu. Jadi murid-murid juga ini juga mengalami kesulitan yang sama.
Jadi, tapi nggak ada gambarnya.
Biasanya adalah navigation menu, annotation. Wait, ah, okay, that's okay, that's okay. Let me try to find out the way that I could help you to get involved in this lesson, like for the next lesson. Okay.
Bentar. Ini kayak di layarnya nggak kelihatan screen-nya kayak dibilang sign in sama sign up. Itu kenapa?
Oh, iya itu memang harus buat akun sepertinya. Harus buat akun juga di Zoom platformnya.
Kok
Maybe
ini?
that's why you couldn't put as annotating.
Tapi ini opsinya doang tuh cuma sign in sama sign up, nggak ada tombol X-nya gitu.
Ah, I see. That's interesting. Let me try to discuss with the rest of the team in case they could find a way for us to solve that kind of thing. That's okay. That's okay. At least we already noticed that you couldn't do the annotation at this moment. Okay. For this round, I'm gonna help you out with that.
Mama, mak, mak,
I'm
mak.
gonna help you with helping you to writing it down.
Wait. Ntar ya.
Okay.
Yuk.
Kenapa dia nggak kelihatan ini?
Memang beda-beda, Ibu. Tiap tampilan Google, sorry, tiap tampilan Zoom itu memang beda-beda sih.
Enggak sih dia dia di luar ininya zoomnya. Dia kayak di layar lain
Layarnya
tiba-tiba.
nggak kelihatan, kakak nggak kelihatan di sini. Coba ini.
Coba aku share. Uh,
Jangan loh, live meeting gitu.
background.
Oh, itu
Oh,
udah.
udah.
Oke.
Sudah bisa
Sudah.
untuk coret-coret sendiri.
Coba ini. Ini kan
Gimana?
ada pensil itu, ada kata pensil. Nah,
Ah,
oh, kemarin Weda yang bisa pakai, nanti pakai apa dia?
Kemarin kalau itu pakai ini,
Dia
Bu.
pakai sama Foya ya, Foya namanya.
Hmm, kurang paham itu kalau itu saya, Bu. Tapi kalau sekarang bisa ditulis nggak?
nggak bisa.
Nggak bisa.
Oh, nggak bisa. Ya udah nggak apa-apa. Nanti saya coba cek untuk bisa buat itu konsisten
Lagi.
seperti apa. Mungkin bisa jadi memang tiap akun berbeda atau mungkin ibu harus buat segala macamnya. Nanti saya coba cek tahu dulu deh, Bu. Nggak apa-apa.
Saya coba cari saudaranya satu yang biasanya dia tarik
Beda
yang
lagi kamar mandi.
apa ada? Sini. Oh, gitu. Ada? Cepetan, mau nanya tentang pensil di laptop itu di mana? Pensil. Terus,
I
terus apa tulisannya? Bisa kamu bantu bentar aja.
cannot see
Nggak ada.
my meeting room.
Ini apa nih?
Yuk, itu email aja.
Cepetan dah. Ya, dah. Cepetan. Gak apa-apa, dah mandi. Ini apa nih, Di?
Itu temperaturnya, Oman, 3 pensil itu nggak ada.
Ini pelajaran kelas berapa ini, Kak?
Ini kelas 4 kok.
Oh.
Ah, gabungin kelas 3 kelas 4. Jadi
Oh,
biar anaknya nggak kaget
itu
ketika
di sini ya. Nggak tahu udah kalau yang ini.
belajar pelajaran baru.
Nggak tahu kalau yang ini waktu itu ada di sini.
Berarti beda-beda template berarti. Nggak kelihatan dia.
Mm-mm. Iya, nggak apa Ibu. Makanya nanti saya coba cari tahu lebih lanjut aja gimana caranya supaya nanti Widi juga bisa terlibat ketika misalkan mengerjakan soal sama-sama sama saya. Gitu. Soalnya kadang ada, kadang nggak ada. Gitu. Nggak apa-apa, nggak apa-apa. Oke, Widi, we can continue first. We can continue first to finish what we have. Probably tomorrow I'm gonna check with the rest of the team inside of my team to help us through that. Okay, now for the square one, we actually don't know yet about the side. We only have the perimeter, right? And then we have to find the side. I already put it right here. Y 4 times S. S refers to side. 4 means as the nature of the square which has the same side. Remember? So if this side is 1, the rest of them would definitely be the same length, right? That's why I put it as 4 times of S. And then I already found from the exercise that the perimeter is 20. Can you tell me how much? What's the length? I mean, what's the length of each side?
I think it's 5 because if the perimeter is 20 and it's times 4, so 4 times 5 is 20, so I think it's 5.
5.
Yes.
Okay, this one is the correct answer. Cool. I'm gonna also help you to add another way possible for you to answer. When it comes to every formula, let's example this formula. The formula for the perimeter of a square is perimeter 4 times of the side. Okay. Now, when we try to understand what's the S, what's the side, that means that we need to only put this class situation alone. There is a kind of method in math where we actually try to find something. We try to eliminate the rest. Eliminate the rest. It's either to move to the other side. It's either to uh, assume it as zero or something like that. But in this case, this 4 has to move to the other side. Okay, how to understand that? Okay, hear me out. For every multiplication like this, once it has to move to the other side. It has to go from multiplication to the division. Okay, but if let's say I'm gonna put it like 4 minus s is actually the parameter. It's just the assumption, not the correct formula to measure the parameter of the square. But if let's say the calculation is minus thing or maybe plus kind of thing, when you try to move it to the other side, it would be like this. From the initial is positive. When you move it to the other side, that would be negative. And then how do we understand this? It's minus s because it was left alone, right? Let it be minus s. Now, when we try to put it as just usual s to know exactly, right, the result as in positive. Remember, positive and negative is actually the same. It's actually the same. It's just in short that they go different way. For plus, they go on the right. For example, if we imagine right is actually on the x coordinate, right? So that means positive 4 goes to the right. Meanwhile, the negative 4 is actually goes to the left, right? But in a lot of cases, we have to find the result, especially for this side, to be in positive, not in negative. Why so? If negative, it would be like this. Usually we draw square like this, right? If you notice that I go from left to right, I see in positive, but if I left them as negative, I draw the square actually from the right to left. Similar when we go in the coordinate x, right? Now, so when we try to convert minus s to be a positive, that means we have to multiply it. Minus multiplied by minus should be plus. Minus multiplied by plus would be minus. That's the thing. Not sure. I believe you haven't learned that at school, right? Minus multiplied by minus would be plus, something like that. Have you learned about that at school?
Yeah, I think I've learned it in grade 5.
Nah, you would learn that on grade 5 later. But basically, that's the kind of thing you could understand the basic from the start. When it comes to the multiplication calculation, when you have to move it into the another section, right? You can actually simplify from multiplication to division. So it's basically 20 as stated here, divide by 4. And then if let's say you want to move it back to this, from the division, move it to the other side, would be back to the same multiplication. That's the basic thing. For every multiplication and division, when you want to move it out to another side, it goes whether division to multiplication again. But when it comes to the plus and minus, you want to move it to the other side, it will go to the plus and minus again. So there is no condition where you actually have division and multiplication and then you move it out to the other side. It goes to the plus and minus thing. Okay, that's the standard. That's the kind of thing that goes similar. Ah, if you're confused about that, your answer is already correct. Where you actually just could imagine that how much, what's the number that actually could give me the result of 20 when it comes to the multiplication by 4. It's also the kind of method, easy method. Now, Oh, okay. Before I continue for the pentagon, do you have any questions so far? You don't
Oh,
have to understand this, don't worry, but at least the basic kind of thing, how to
mm,
measure.
I don't have any question yet.
Okay. Okay, that's the kind of thing that we are probably learned on the fifth grade. Don't worry, don't have to rush in. You are still on fourth.
No, I'm already grade 6.
Okay. Cool one. Ah, that's probably something that I will often use that. Okay, don't worry about that. To get you used to it. Now, if let's say this is the pentagon, if this is the pentagon, its side is 6. So what's the perimeter for that?
What if it said is 6?
So
Hmm.
what's the perimeter for this?
So there's 5 sides, right?
Yes, 5 sides.
So 5 times 6 is 30.
Okay. Cool. 6 is 30. Cool. Okay. Between all of these three shapes, which one is actually hardest for you to understand?
Um, it's probably like it's either the square or the pentagon.
The pentagon. Okay, this one.
It's like
Okay.
the square or the pentagon.
Oh,
Like
okay.
I think square is hard because like you put some like complex math there.
Ah, yes, indeed. Indeed. For this exercise, actually, it adds a bit complex calculation. But don't worry, I'm gonna try to to put it you to get used to it. At least I know that this is something that actually you have learned already at your grade, right? Especially that you are on 6. I'm gonna try to put it as what I call as a converse calculation. So we are going to use this similar kind of thing, but we try to put it into different calculation. Let's try a bit. For example, I change this. I change all the side to 5 and then 4 and then I left it blank. Okay. Now I could identify from that exercise that the perimeter for this triangle is 17. Okay. Can you help me to put out what's the length of the side? Let's try this a bit. As in, for the perimeter, since each side is actually different, let's just try to assume that the first plus the second and the third side, okay, as the rough calculation, right? Now, we have this formula as the basic model that we understand. And then, what's the next step?
I think you like first the 5 and 4 equals 9 and then like you minus 17 by 9.
Okay, good job to identify that. Okay, since the only thing that we don't have yet is the third side, okay, and this is referring to the addition calculation, right? That means that the third side has to stand alone. The rest of this number should move to the left side. The initial began with the plus positive number. When we move it to the left side, they have to be minus. Minus 4, minus 5. That's the way that we find the third side. Good job. That means, like you said before, 17 minus 9 would be 8 as the third side. So
Yes.
there is no way that we actually found that when we move 4 and 5 to the left side, it would be like 17 divide 4 plus 5. No, that's not the way that we actually calculate that. Okay, now, if let's say, I'm gonna flip that around. If for the pentagon, each side, we don't know yet, but we only have the perimeter for like 20 is the perimeter. And we already understand that each side of this pentagon consists of the same length, right? So there would be 5 since it is pentagon. Penta means 5, means S, correct? So what's the S?
Mm, 4.
4, since you move it from multiplication to the bottom, it goes for the division. 20 divided by 5 would be 4, is the side. Why don't we put minus S?
I don't know.
Since it began with the positive value already, right? And then we try to know the exact number, right? From this side means that only 5 needs to move to the other side. The second one, since it is the kind of multiplication as it initial, right? We don't change any kind of things unless the formula goes like this: 5 multiple minus S. If there is a clean statement in that kind of calculation, yes, you could put it as minus S, as kind of like the thing that you have to find the exact answer. Do you get me?
Um, like
So if it goes
this.
like this, yes, you can put it as minus S. But if from the initial you just only have like this 5 times of S, you want to find the S, you just move this 5 to the bottom side. Why? Since it initially began with the multiplication, you move it to the left side means that you put it into the division. You get me now?
Yes.
Okay, don't worry about that. We don't have to put a lot of pressure into that. We will try to have some sort of tweak into the all kind of the things that we already learned from your previous grade. So you're not only gonna refresh the materials from your previous grade, but also try to have some kind of having fun by tweaking a bit, okay? And then we try to then learn new things lah, I can say. Okay? Anything you'd like to ask before I end this lesson?
Nothing.
Nothing. Okay, cool. If you have any question, just feel free to drop me a message after the class. Feel free to have my contact to your parents. But in case you don't have any, see you on Thursday. Thank you so much, Widi. Bye bye.
Goodbye.